Good morning, everyone, and welcome to the July 2023 edition of the Southeast Monthly Climate Webinar, where we talk about the climate and special topics pertaining to the Southeast region. My name is Chris Furman, the regional climatologist with NOAA's Southeast Regional Climate Center, and I'll be giving a climate overview of the past month. Our other speakers today are Jeff Dober from the Southeast River Forecast Center, who will provide a water resources update, Pam Knox from the University of Georgia, who will provide an agricultural impacts update, and this morning, we're pleased to have Dr. Lee Ellenberg from the University of Alabama in Huntsville, who will be discussing flash drought in the Southeast and highlighting some of the work he and his colleagues have been doing in Alabama. So again, thank you all for joining us. Just a reminder to type your questions and comments into the question box at any time, and they'll be answered at the end. Also, a recap email of this webinar will be sent out with a YouTube link to the recording in the next few days. All right, so let's get started with an overview of the climate. Next slide. So over the past 30 days, we see that temperatures have continued to run below average across much of the interior of the region, while the southern portion of the region, including the Caribbean, has experienced above average temperatures over the past month. Through Sunday, many long-term stations across Florida, including Jacksonville, Tampa, Fort Myers, Miami, and Key West, are on track to record their warmest July on record. In fact, on Sunday, Miami tied its all-time warmest daily average temperature of 90 degrees in a record going back to 1895. The humidity has also made conditions particularly oppressive, as heat index values have exceeded 115 degrees in places. Unfortunately, as we'll see in a minute, the heat is likely to linger in the short term, and above average temperatures may persist into the fall. The same holds true for the Caribbean, where many locations in Puerto Rico and the US Virgin Islands are off to one of their warmest starts to the summer on record. Okay, next slide, please. So as is typical during the summer, precipitation was quite variable over the past month. Much of Tennessee, Alabama, and Virginia have been wetter than average, with some localized flooding, while Georgia and Florida have been drier than average. Looking more closely at Florida, we can see that, that the western side of the peninsula has been especially dry, while much of the Space and Gold Coast to the east have been a bit wetter than average. This pattern has been tied to the persistent ridge or dome of high pressure that's been sitting over Texas for much of the summer, which has shifted much of the precipitation to the eastern side of Florida. Precipitation has also been variable across the Caribbean, though many places continue to experience long-term moisture deficits. Fortunately, the island of St. Croix, which we've been monitoring closely now for several months, did receive beneficial rainfall over the past couple weeks, and there's some optimism that conditions will continue to improve as we transition to a more climatologically wet period. Okay, next slide. Now, I did want to highlight one notable weather event from this past week. Last Wednesday, a tornado with estimated peak winds of 150 miles an hour, that makes it a high-end EF3 tornado, tracked over 16 miles across portions of Nash and Edgecombe counties in eastern North Carolina, just north of the town of Rocky Mount. This is the first EF3 tornado recorded in the state of North Carolina in the month of July since records began in 1950. And it's only the third EF3 or greater tornado recorded in the state during meteorological summer. At least 16 people were injured, too, with life-threatening injuries, though no fatalities, fortunately, have been reported or confirmed. Within the area of EF3 damage, you see there on the left is a large Pfizer plant, which makes nearly a quarter of all its sterile injectable medicines used in US hospitals. And so it's expected that the damage sustained by the facility there in the image on the left will affect drug supplies nationally. Okay, next slide. Looking at the drought monitor, we continue to see improvements across the region, in particular across parts of eastern Tennessee, northern Alabama, and northern Virginia. Georgia and South Carolina are currently free of any drought designation, while just a small pocket of abnormal dryness remains in northeastern North Carolina. Small areas of moderate drought continue to linger across western Tennessee and northern Virginia. In contrast, the warm and dry weather that's dominated across the western panhandle of Florida has led to a reemergence of moderate and severe drought along the I-75 corridor between Tampa and Fort Myers. Okay, next slide. Looking in the Caribbean, we see some subtle changes across Puerto Rico. The area of abnormal dryness across the eastern half of the island has contracted a bit, while the pocket of severe drought to the northwest improved to moderate drought over the past month. Severe drought persisted across St. John, while extreme drought emerged on St. Thomas. As mentioned earlier, St. Croix did receive some beneficial rainfall recently, and this contributed to a 1-category improvement from exceptional to extreme drought. Though 6 to 9 month deficits in rainfall and moisture remain, which reflect the long-term drought conditions on the island. Okay, next slide. Turning to ENSO, not much change from last month. Forecast confidence remains very high, over 90%, that El Nino will persist through the upcoming or through the current hurricane season and through the upcoming winter. According to the Climate Prediction Center, there's about an 80% chance that this event will peak at moderate to strong intensity this winter, and about a 20% chance that it may become a historically strong event like the ones from 1997, 1998, and 2015 and 2016. Okay, next slide. So looking out over the next 3 months, as we close out summer and head into fall, we see that the CPC continues to forecast above average temperatures across the region. Precipitation is leaning above average across the middle portion of the region, with equal chances of above or below average precipitation elsewhere. Next slide. So in response to some feedback, we're now going to provide 3-month outlooks for the Caribbean region. The maps here show temperature and precipitation anomalies based on a multi-model ensemble from several different agencies called the North American Multi-Model Ensemble, or NMME. This particular ensemble is forecasting above average temperatures across the region over the next several months, as well as above average precipitation, which is certainly encouraging news for those areas dealing with long-term drought impacts. Okay, next slide. Speaking of drought, the seasonal outlook continues to look good, with drought removal likely across the entire region, including Puerto Rico, and no new development is expected. Okay, next slide. So now that we're into the heart of the hurricane season, we'll be providing 2 to 7 day tropical outlooks for the Atlantic Basin from the National Hurricane Center. As of last evening, the NHC was still monitoring a tropical wave, Invest 95, that's slowly moving westward toward the Lesser Antilles. And while the chances of development remain small, the system is expected to bring rain, wind, and choppy waters to Puerto Rico and the Virgin Islands over the next several days. Yesterday, the NHC also identified a weak trough of low pressure that's expected to move towards the southeast coast later this week, though the chances of development remain low at this time. Next slide. So in the short term, confidence is high. The temperatures will be above average across the region. Below average precipitation is expected to persist across much of the southern half of the region, while the northern tier is leaning above average. Next slide. Looking at the 7-day QPF from yesterday evening, we see that over an inch of rain is expected across much of the Florida Peninsula and in extreme northern Virginia, while the rest of the region is expected to be a bit drier. Now, of course, this could change depending on what happens to the system currently located south of Bermuda, so definitely worth paying attention to here in the short term, at least over the next several days and into the weekend. Next slide. Looking out to 2 weeks, we see a continuation of warm weather across much of the region, with drier than average conditions persisting along the Gulf Coast, though there's an indication of maybe a trough moving through the Great Lakes and Northeast, and that could bring precipitation and possibly some temperature swings across the northern tier of the region, so we'll be watching that closely as well. Next slide. And if we look out 3 to 4 weeks to about mid-August, we see yet again above average temperatures persisting across the region, with precipitation leaning above average, in particular along the East Coast and across the Florida Peninsula, with equal chances elsewhere. Okay, next slide. Okay, so thank you all very much for your attention. Here's a summary for you to look over after the webinar. Also happy to answer any questions at the end. And with that, I'll turn it over to Jeff.
Great, thanks, Chris. And let's take a look at, so Chris gave you the climate outlooks, and let's take a look at how that's going to affect stream flows. And we'll start looking at where we're at currently with the 28-day average stream flows. Really not much change from what our information we provided in June, and not really much change as far as stream flows. You can see on the left there, a lot of green dots showing near normal stream flows as far as 28-day averages. There's some pockets of, you can see the blue colors there, some pockets of slightly above average, but for the most part, near normal to slightly above normal. And then we, as we always do, show the regional duration hydrograph of the 28-day average stream flows. And it's really interesting how much, as we look past the last couple of years, how much we've been in that green or near normal range. And that seems to continue. We'll talk more about the forecast here shortly. But we did pop up into the above normal range as far as the region with that wet weather in late June and around the 4th of July. But again, we'll be probably treading in that green range as we move forward. Let's go and we'll break it down state by state. And really each area, each state area looks very similar to the overall region, where we had a little bit of a wet period there in mid to late June and into the early part of July that got us in the above normal range. Let's slide to the next slide and we'll work eastward into the Carolinas, and more of the same, pretty much near normal with a little bit of a bounce with the thunderstorm activity in June. So stream flow is looking good across most of the region. And we'll slide to the next slide and show you the current conditions, and really not much of any flooding. We do have some high water down in South Florida, moving into Lake Okeechobee. But for the most part, stream flow is looking good and not really any flood potential really in the short term. We'll go to the next slide. And again, we always show you this, where we're at as far as river flood climatology, the season. We're in week 30 and we're sort of in that summer lull period. Not really much activity typically for most of the region. The exception is, if we go to the next slide, the Florida Peninsula, where we start to get into the wet season, which leads into the tropical season. We're in week 30. This is a period where we do see some, in most cases, some ramp up in higher water and potential flooding, and especially in central Florida, the Tampa area, and as we see currently in the South Florida, Lake Okeechobee area. And so we'll keep an eye on this. As Chris pointed out, we do have that tropical system that's sitting out there south of Bermuda. We'll be watching that closely as well. We'll go to the next slide here. And we showed this last month. This is the Southeast tropical storms looking back 1960 to 21. This is the regional area by week of the year. And you can see we really do have two, as far as storms affecting the Southeast, we really, in a historical perspective, we do have two sort of periods there, a June, early July period, and then a later period. And so we're sort of in the middle of those two periods right now. We'll go to the next slide. And so we'll give you the overall. We're still calling for near normal risk for river flooding, really pretty much the same as we were calling for in June. Near normal stream flows. Stream flows typically fall off this time of year with the warmer temperatures and less organized precipitation. The exception is, again, Florida, the Florida Peninsula. But right now we're looking at near normal sort of summertime stream flows and typical flooding for this time of year. And that's all I had, and I'll go ahead and pass it off to Meredith.
And I'm going to pass it off to Chris.
Okay, thank you, Meredith. Yeah, so unfortunately, Pam was not able to make this month's webinar, so I'll be covering her slides this morning. So we'll go ahead and get started. So one of the benefits to the warmer and mostly drier conditions over the past month is that it's allowed not only crops to get caught up, but it's also given farmers and operators a chance to get out and get some field work done, in particular applying fungicides. However, the heat and lack of rainfall in places have led to some issues, such as spider mite damage, as shown in the figure in the upper left. Areas that have gotten a good bit of rain, in particular places in Alabama, Southwest Georgia, and the Florida Panhandle, saw crops struggle because of the flooded fields. High moisture levels have also contributed to southern blight, as seen in the photo there in the lower left. On the other hand, the warm and dry weather helped forage producers cut and dry quite a bit of hay. Unfortunately, the extreme heat and humidity across parts of the region have had a negative effect on cattle and livestock, requiring extra water and shade to minimize heat stress. In general, though, many crops are looking great, and yields so far have been good. Okay, next slide. As we discussed earlier, rainfall's been quite variable over the past month. Some places have been exceptionally wet and humid, with many days of measurable rainfall, while some other places have largely missed out. Many areas across Virginia, eastern Tennessee, Alabama, and southeast Florida have experienced one of their top 10 highest counts of days with measurable rainfall over the past month. And this has led to an explosion of fungal diseases, including tar spot on corn and white mold on peanuts, as shown there in the photos below. In contrast, other places have experienced one of their lowest counts of days with measurable rain over the past month, including Southwest Florida, as we mentioned, which has resulted in an expansion and intensification of drought, and it looks like that's going to continue this week as well. Okay, next slide. Soil temperatures across the region have been mostly near average over the past month, except across South Florida, as well as Northern Virginia and parts of northeastern North Carolina, where soil moisture has been above average, while soil moisture has been above average across the northern tier of the region and below average across parts of Georgia, Alabama, and North Florida. Okay, next slide. The recent return to more summer-like temperatures means that crops are back to accumulating their historical number of growing degree days. And if we look across southern Georgia and much of Florida, where crops were off to a really slow start this season, we see that they've really been able to catch up in recent weeks, helping speed up development as we round the corner here of the growing season. Okay, next slide. Okay, so here's Pam's summary slide for you to look over after the webinar. And now I'm very pleased to introduce our guest speaker this month, Dr. Lee Ellenberg from the University of Alabama in Huntsville, and also the Alabama Associate State Climatologist. And he'll be talking about flash drought in the region. Lee, the floor is yours.
Fantastic. Can you guys hear me okay?
You're coming in great.
Perfect. Perfect. And my screen is, all right. Great. Well, thanks so much for having me this month. This is a webinar that I really enjoy attending, very informative, and I've always really enjoyed the special topics at the end. So I'm happy to be a part of that this month. So as the title says, and as I was introduced, I'm going to be talking about flash drought in the Southeast. Essentially take a quick review over the past couple events that are well known and talk specifically about some of the characteristics of the Southeast when it comes to flash drought. This is all in lead up to a bigger project that we have going on and doing a broader assessment of flash droughts in the Southeast. So this is kind of the initial stab, I guess you will, at where we're starting from, kind of taking an assessment of using metrics and techniques that we have. But my name is Lee Ellenberg. I'm an associate state climatologist in Alabama and work here at the University of Alabama Huntsville as a research engineer. So just to start out, what is flash drought? I know most of us on this call have probably heard about flash drought many times, and you may already know. But simply put, it's the rapid onset or intensification of a drought that leads to a certain impact. And I focus a lot on agricultural impacts, so that impact would be reduced crop yield or crop failure. But it's important to note that flash droughts can have impacts beyond agriculture, especially when an ongoing drought intensifies quickly. So there's just a note that it's not just agriculture, even though agriculture is probably one of the main impacts of a flash drought. So rapid onset and intensification. So I have two figures here at the bottom of the screen. One looking at the 2006 to 2008 drought in the Southeast. If anyone's been around long enough, remembers this well. And then on the right side, I have two what's considered flash droughts, the 2016 and 2019 droughts. And this is just to further emphasize the difference in what we're talking about here is not a prolonged drought that lasts several years, but one that could be has a very quick onset, and depending on the duration, a short to medium-term duration, but the real kick is the quick intensification of the drought. And so I'm just showing these two to kind of show the differences. Also pointed here at the bottom of the screen is the drought.gov website talking about flash drought. So a lot of information that I pull from this and that I pulled previously comes from drought.gov, has a really great resource of information on flash droughts. So common definitions for flash droughts, there's a lot of definitions, but we'll keep it simple and say the onset of flash drought really occurs three different phenomena. One is the lack of rainfall. So we have below normal rainfall. What this does is increases our evaporative deficit. That means we have less supply than we do the demand of the atmosphere because we didn't get enough rain. This typically results into an increase in temperature, thus further increasing the evaporative deficit. And then we also may have increased wind speeds, which is a separate forcing that could also have an impact on the evaporative demand. So I have this little a couple, little arrows here in the top right, kind of just showing this cycle. We get below normal rainfall. This kind of accelerates our evaporative deficit cycle, which in turn reduces soil moisture, which in turn creates less moisture on the surface, which creates higher temperatures, which creates, so we're in a feedback loop that can really intensify quickly, especially in regions like the Southeast. Common indicators of flash drought are evaporative stress, as you can see there in my little cartoon, soil moisture, and typically when we're looking at flash drought, we're looking at short-term rainfall deficits, so 30 days or less. So there's a lot of different ways to classify a flash drought. It's so many days without rainfall. There's a percentile drop in soil moisture, but just to keep it simple, it's essentially this short-term hydrologic cycle of reduced rainfall, increased temperatures, increased evaporative demand, resulting in soil moisture drops. And again, you can kind of see what I have here on the bottom is the 2006 and 8 long-term drought or bigger drought that we know sometimes just termed as the 2007 drought, and the two 2016 and 2019 droughts. It's important to note that there is a lot of some literature out there claiming, or not claiming, but just stating that flash droughts are really primarily defined by their intensification. And so having a rapid intensification within a larger term drought or a longer term drought could also be considered a flash intensification or a flash drought in and of itself. And I wanted to just point that out. You have in the 2006-8 drought, there was a really intense intensification that mimics that of the 2019 and the 2016 drought. However, typically when we're looking back the 2016 and 2019 is what we consider flash droughts. But just to point out that in the broader sense of the definition, the rapid intensification of an ongoing drought could also be considered a flash drought. And here I'll also point out there's a really great definition indicators and where we go from here, a paper by Joel et al. In 2021, Making Sense of Flash Drought. It goes through a lot of these definitions and what's been presented in the literature. So I want to highlight that, and that's also available on that drought.gov webpage. So I'm going to go through a couple different indices that we're currently using, that we use when we're looking to monitor flash drought and towards what we're going to be using in the broader assessment. And then I want to go through a couple different that look at some past events and talk about them. So before I go into looking at the past events, I wanted to talk about a couple of the indices that we use. The Evaporative Stress Index. Essentially, this is a product coming that we received from the NASA Sport. But it's based off a couple different papers. Anderson, Otkin, Anderson et al. Is one who the definition of the product itself, and then Otkin's application of it on flash drought. Essentially, the evaporative stress index is the ratio of actual evapotranspiration divided by the potential evapotranspiration. And what we mean by there is essentially the environmental supply, how much water is there to evaporate, and how much demand from the atmosphere is there to evaporate. And so the lower that ratio gets, the demand is greater than the supply, and therefore we're in a dry situation. If that ratio is above zero, then we have more than enough water than that's demanded from the atmosphere. And so this evaporative demand is a really a good indicator of the onset and intensity of flash droughts. This figure to the right, this is a plot showing the evaporative stress index in relation to precipitation deficits and the drought monitor, just highlighting that the evaporative stress index does have a significant 2 to 4 week lead time in assessing and capturing the ongoing of a flash drought. And so this is why evaporative stress, or the evaporative demand, is a really important term in discussing and identifying flash drought. The second index I'd like to show is the lawn and garden index. This is a pretty simple index that we produce out of the State Climate Office in Alabama. But what this does is this combines both the precipitation component and the atmospheric demand, the evaporative demand. So what we do to create this product is we create a 21-day effective precipitation. Essentially, what we're doing is we're taking the last 7 days of precipitation, because that's very important to the current lawn and garden and short-rooted vegetation, with also recognizing that rain beyond the 7-day period could also still be quite beneficial. So we weight that at a trailing distribution all the way down to about 21 days. And so we have a 21-day effective precipitation. What this says, if it rains, an average, a net of 3 inches over that 3-week period, the effective rainfall would be 2 inches, essentially saying that we're going to fully calculate the last 7 days and then wait the previous 2 weeks. And then what we do is we difference that between what we are expecting as the actual evaporation that's required. And so we have this is a static curve that basically goes from half an inch of precipitation needed based off the evaporative demand and the ecosystems that we have in the Southeast, all the way up to 2 inches in the middle of the summer. And so we difference those, and we end up with a LGI, a lawn and garden index, that's less than 0. That means it's dry. As a matter of minimum, it'll never go below 2, because that's the maximum amount of precipitation that we need. And if LGI is greater than 0, then we're essentially in a wet pattern. The last thing I'll talk about is the drought monitor, which I'm sure we're all pretty familiar with. The US Drought Monitor is a composite index, or a composite indicator of drought, that takes a lot of different physical data sets, impact data sets, and feedback to create a unified, simple, easy to interpret index of drought, ranging from D0, anomalous conditions, all the way to D4, which is very dry conditions in the 2 percentile range. What I'm going to be using in some of the plots later is the drought severity category index. And so I'm going to be combining these into one index. And so I just wanted to point that out there. If you want more information, you can go to the Drought Monitor website for what that looks like. And the drought severity and coverage index is essentially just adding up the coverages of these droughts all together to get one index. So we can represent how severe and the coverage of that drought for a particular region. So with that, we have three kind of indices that we'll be talking about: the ESI, the LGI, and the US Drought Monitor. One is looking at evaporative demand, one is the evaporative demand and precipitation, and the third is the composite drought monitor. So a couple well-known events in the Southeast. We have if you ask someone what are the biggest flash droughts that we've had in the Southeast, they would probably tell you the 2016 flash drought and the 2019 flash drought. The 2016 flash drought is unique in that it was widespread over the entire Southeast. It was a bit longer than the 2019 drought. This lasted most of the year 2016 and into 2017 before relief was seen. And then another interesting aspect of the 2016 drought, which you can see here, is there was ongoing kind of typical drought patterns at the beginning of the year, with a rapid intensification in the October-November timeframe. The fall 2019 drought is different in that it was truly a rapid onset and short duration drought. Essentially, it didn't rain in September for most places in the Southeast. This was September is a very hot month for the region, and we already have low precipitation normals in this region or in this time frame, and so in 2019, essentially the spigot was cut off and there was very little rain in the Southeast in general. For the most part, I think most states and most regions had the lowest precipitation on record for the fall of 2019 for September. So we're going to take a look at these two droughts. I'll show you using some of these indicators how we look at them, and then we'll continue on to a third flash drought in the Southeast. So I have an animation here looping through the ESI. This is the Evaporative Stress Index for that 2016 drought. And I recommend just taking a look at one figure at a time. So if we look at the left side of the map, you can see the ESI red is below normal and negative, very dry conditions. And so you can see we're already in a pretty dry condition come in September. This is because the ongoing drought. And then towards the end of September and October, we have a very intense intensification. And this can be seen. I'm looking at just I think this is Russell County, Alabama, where I've highlighted from some reported impacts. And you can see on the right-hand side, this is the time series progression of this drought. Starting out kind of a dry period before August. We had some rainfall, and then at September we start a precipitous drop in our ESI from a 1 all the way down to a negative, almost to a -3. So that's a very steep drop, just kind of highlighting the intensification of this drought and what it looks like. Here's a snapshot of what that drought looks like using all three of these indicators. So I'm going to walk you through this panel. Up the top left is the ESI that we just looked at, and so this is the 2016 September 16th snapshot of ESI, and this is 2 months later in November of what the ESI looks like. So you see a rapid intensification, a 2-month rapid intensification. If you look below in this same image, you can see there's two real intensifications. The first is that September to October, where you have a 3-point drop nearly, and then you have a further intensification highlighted by the lighter red box. So both of these are in whatever metric you want to use to identify a flash drought, whether it's a change anomaly in ESI, whether it's a difference. These are both identified as flash droughts using this metric. This is also captured really well in the LGI. So if you look at the middle plot here, you can see again in 2016 September, we have relatively dry conditions across the state. And then by 2016, by October 14th, you have a rapid intensification. And again, this is seen in the time series below, where you have a near 2-point drop in a 3-week period, and then a further intensification as well. And then you can see this also represented in the Drought Monitor, where we have a drought severity and coverage index. So this is a composite of all the different categories and their coverage. You can see a rapid increase at the end of September, and then another rapid increase towards the end of November. One thing to note, you can note here, and we'll note in the 2019 drought as well, is the Drought Monitor tends to be a little bit behind the curve on the intensification of these events. And part of that is just because the Drought Monitor is trying to take into account every aspect of drought and every time scale. So when you're looking at short-term droughts, the Drought Monitor is taking into account hydrologic droughts and composite indicators from all sectors and from all time periods. And so necessarily it tends to be a little bit behind, or it lags in being able to capture the extremeness of the flash drought. And the Drought Monitor itself is not meant to capture flash droughts. It's meant to characterize broad-scale unified droughts. So I think that's well known. And so just another point to make here. So now we'll move on to the 2016 drought. So this drought is very different in that it was almost very normal wet conditions before September 2019. So this is an animation of the Lawn and Garden Index showing an incredible drop, essentially from the beginning of September through mid-October. So you can see on the left-hand side here, I'm looking at Autauga County in Alabama. This is showing what I said earlier, essentially about a month of precipitation that just didn't happen. So you can see here again from the right-hand side of the plot, we have an LGI of above 2, which is pretty wet conditions starting September. By mid-September, so literally 2 weeks into the month, we've dropped down to a negative LGI, showing that there is essentially no rainfall. We can take another look at this. Hopefully this figure is a little more familiar now. So we have on the left side, we're going to have the ESI panel. In the middle, we have our LGI, and on the right, we have our drought monitor. So if you take a look at the ESI, again, what we can see is, this is the same figure. Sorry, I'm missing the 2019 drought. But you can see here, the panels above are still showing the 2016, but the graphs on the bottom are showing the 2019. So I apologize about that. But again, what we can see are these flash drought trigger points. So in all indicators, we show flash drought occurring here and picked up by all 3 of these indicators to some extent or more. Again, the LGI is the earliest to pick this flash drought up, and alongside with the ESI. And then at the end, you can see the drought monitor shows an initial intensification at the beginning of September, but really shows the final, the severity of the drought towards the end of October. So all of these are defined as trigger points in whatever metric you would like to use. These are kind of quintessential flash drought events that we've seen in the Southeast, the 2016 and the 2019 flash drought. So the rest of the presentation, I want to talk about different aspects of flash drought in the Southeast, and I don't know if hidden is the right word here, but maybe the overlooked flash droughts. So as we mentioned at the beginning of the presentation, flash droughts, by many definitions, are chiefly defined by their impacts. And so I want to walk through an example of a flash drought that doesn't make the headlines in terms of flash droughts or are included in some of these the broader reviews and assessments across the country. So, for example, in Alabama, our corn reaches its most critical moisture stage, its silking stage, during a 3 to 4 week period between the end of June and the 1st of July. This is a time when we have really high temperatures and extremely variable precipitation. And what this does is it leads to a constant risk of impacts from these short-term flash droughts. The figure I'm showing here, this is courtesy of Dr. Ortiz at Auburn University, showing the crop water demand. Again, this is from a corn crop, but can be related to other crops. We use corn a lot because it's a water hog, if you will. And so what we have here, I'm showing on this plot, is the crop water demand in the gray bars, and then the rainfall. And what we can see from this plot is the red, any number above those bars that's red means there's a deficit of amount of water that we received that June compared to the amount of water that a healthy corn crop would use. So precipitation amounts range from anywhere from 2 to almost 7 inches. Right, so we have a extremely variable precipitation. That if you get a thunderstorm on top of you, if like that could change. You might have 7 inches. If it's a normal, it just ranges a huge range from 2 to 7 inches. However, the crop water demand is pretty consistent, almost always around 5 inches. So what this results in is a precipitation deficit nearly 75% of the time. That's a lot of time that we don't have the correct amount of, or the appropriate amount of water for certain types of agriculture. So this is the 2022 flash drought that I want to highlight here. So this is in that June and July period, and so this is the drought monitor showing if you look at the far left corner of Alabama, this is in Lauderdale County, and we show basically starting of June, things start to dry out pretty quickly, and we have a 200-point increase in the drought severity and coverage index. And that's essentially over the June-July period. let's take a look at, and so we go from a category, essentially a category 0, all the way up to a category 2 within a 1 month period. This would be termed a flash drought by many metrics. We can take a look at this in terms of our lawn and garden index, and what we can see here is, again, a very extreme departure of our LGI. So starting at the beginning of June, a relatively normal, wet to normal, May, and then once June occurs, essentially just like in 2016, except now in the middle of the growing season, we have the spigot turns off. There's essentially no rainfall that occurs most of the month of June. We can see here almost a 3-point decline in a matter of weeks. The first super rapid decline essentially translates to 0 rainfall, and that goes from above about 1.8 all the way down to a 0.8, a negative 0.8, and then the larger decline encapsulated by the lighter red box here, showing a full decline from 1.5 to negative 1.5. So that's a 3-point drop across less than a 1 month period. This is what I call a flash drought in the most extreme case. However, I think these are a lot more common in the Southeast than we realize. I want to dive into this particular event a little bit closer, and the 2022 flash drought. So the figure you see on the left here for this same period, this is the weekly precipitation for this watershed that we're looking at in Northwest Alabama. So while the seasonal average precipitation was pretty close to normal, so we had 25 out of expected 30 inches of rain for this region, we had essentially 2 weeks, 2 consecutive weeks, that's important to note, 2 consecutive weeks with negligible rainfall right at the end of June, followed by a below average amount the week after. So this is what, when we talk about flash droughts in the Southeast, a lot of times we say you're always a week or 2 away. You're always 2 weeks away from a drought. You're always a week away from a drought, and that's because in the middle of the summer, when our evaporative demand is so high, all it takes is 1 week without that moisture, and it creates some pretty dry conditions. I want to show this also represented in soil moisture. So we have a NRCS scan station right in this same location. So it was very convenient to have this kind of data. And so we can see this same time period from the June to July, and we can see that on June 18th, soil moisture was near the 75th percentile. So actually, wetter than normal. By July, by July 1st, it was already at the 10th percentile range. So that is a 75 percentile drop in a matter of a month. And so this caused really major impacts in the agricultural industry in this region. So this area is responsible for the 3rd, 5th, and 6th top corn producing counties in the state. So this is a very high productive corn region. You can see here, I have a figure here. This is the USD Nass County yields from 2010 to 2022. And it shows that this region in 2022 had a 40% of their normal crop yield. If you go talk to any farmer or even the Ag Research Institute in this region, they'll all tell you if you had rain fed, you pretty much lost every bit of your crop. The interesting thing about the Nass County yields in this region is that there's not enough irrigation to part out irrigation versus rain fed. So that 2022 yield of 100 bushels per acre, that's the average of rain fed and irrigated. So even if you were a rain fed, you probably had a pretty significant less crop yield than even that shows. What this event really highlights, and what I want to, the kind of takeaway here, is that even in normal to close normal seasonal patterns or seasonal precipitation, if the timing of the rainfall is not adequate, and by timing, we're talking 1 to 2 weeks, as we just demonstrated, crops can suffer extensive damage from flash drought. So why is this unique to the Southeast? So flash droughts are particularly acute because of the conditions that we just talked about. We have a lot of rainfall, right? We get on average anywhere from 50 to 70 inches of rainfall across. However, our ecosystems have evolved in that environment and generates a really rapid hydrologic cycle. This is my favorite picture to show. I teach a hydrology class, and this is what I show in day one, show the students. This is an averaged depth of precipitation and stream flow, or runoff, if you will, over. I think this is the Middle Alabama basin that I took, but it applies to most areas in the Southeast, where we have a pretty average amount of rainfall, about 4 inches on average every month, with a peak there in March and a trough in October. So that's where we get the lowest amount of rainfall. However, we still get pretty distinct, it's pretty stable across the years. However, if you look at our stream flow, so this is stream flow that's been backed out into runoff, so we're in the same units here. You see a rapid decline in stream flow starting about June, July, as we just heard about previously from the USGS. So what's causing this? What's causing this rapid departure? You would think they would be a lot more related to each other. Well, if we add one more figure on here, and sorry, it turned out a little blurrier than I hoped. If we add our evapotranspiration on here, now we can see that, well, this is what's causing this rapid decline in stream flows. So we have, and when we talk about a rapid cycle in the Southeast, this is what we mean. We have a lot of rainfall, but that we have a lot of very green and deep-rooted vegetation, natural vegetation that produces a lot of latent energy and uses a lot of water. And so this is the average water balance across the Southeast, or in the Middle Alabama here. And you can see on average, we're showing what we showed earlier. In June, we have a precipitation deficit. Not every year, but on average, we have a precipitation deficit. And then also in the September and October range, we're kind of flirting with that same line, where our ET is starting to taper off, but so is our precipitation. So we have these two really sensitive points of flash droughts, because and when I say this, I mean that on average, our precipitation sometimes doesn't meet the demand especially for agriculture. And so that's what we're showing here. And this is what we mean by a rapid hydrologic cycle, and it shows the sensitivities and the risks that we have in this region, both during growing seasons and again towards the end of the fall. So again, here I have the error bars kind of showing this is the range of rainfall, the average rate of rainfall. This is averaged over a very large area, so you don't see a huge swings. But again, this average, I think, really points out an important aspect of flash drought in the Southeast. So this is some of the work that we've done in the past is looking at this June precipitation and relating it to crop yield, basically showing that June precipitation is extremely variable, and it's a really good indicator of crop yield. The green line here is our yield. This is at a station in Headland, Alabama. The June is our precipitation, our precipitation minus evaporation, essentially our precipitation, our water deficit. And so from some economics that we did, a long-term sustainable yield about 110, that essentially covers your input cost, shows that and it's responsible for this June precipitation that in many cases the rain-fed farmers are below the sustainable yield. In fact, nearly half the time, if you're just depending on rainfall in the Southeast to grow corn, you're playing some pretty risky game, and that's again because of our rapid hydrologic cycle, the precipitation deficits in June. And so these are ways that we're starting to try and quantify the impacts of these flash droughts and what the risk entails. We've started looking at flash droughts across the whole region to essentially try to do a better assessment of when these occur and where these occur. So this is just a very initial look at flash droughts across the Southeast. This is the Drought Monitor category degradation approach. So if we've had the drought monitor degrade 2 periods or two categories over a 1 month period, so 2 weeks over a 4-week period. We call that a flash drought. So you can see here, this is across the southeast, and you'll notice the bottom part of Florida is missing, and that's just because the data that we had when we did this it considered mostly the panhandle. So apologies for those in South Florida. What you can see here is our flash droughts are pretty common as this is the growing season. So this is just looking at May to September. So out of 22 years, there are certain regions that have flash drought nearly every other year or half the time. And in other areas, it's unlikely. And so this is starting to help us identify where these are and what are the drivers of these flash droughts. We have very a wide range of soil types and vegetations across the southeast. And so this is our first step at starting to understand this, and then we're going to be diving deeper in the broader assessment. You can look at the autumn season. So this is where the 2016 and the 2019 drought really intensified and are defined. And again, you can see some pretty high occurrences of these fall kind of September, October drought periods that are very susceptible for flash droughts in the southeast. And so this type of information will help us continue to investigate this and hopefully be able to provide risk and vulnerability assessments of flash drought in the southeast. Real quick, predicting flash droughts. So just to note that flash drought onset we're talking about in the seasonal to subseasonal forecast range, and so we're looking at weeks to months. So essentially our forecasts are going to be limited by the scale of the forecast themselves. So we know that the rapid changes in evapotranspiration and soil moisture are good indicators. And as such, the NOAA CPC has started an experimental 8 to 14 day forecast of flash droughts or flash drought hazards. It's in their hazard outlook experimental page. And so there are some products out there that are attempting to try and forecast or at least give an outlook of flash drought susceptibility. So I wanted to point that out. There's still a lot of uncertainty, again, just with the forecast themselves, and also being able to change, identifying what conditions mean, what antecedent conditions are there for flash droughts. So I'm going to end here, essentially talking about this last flash, the Southeast flash drought assessment, which this is the very beginning of this project that we're looking at. And so we want to provide a really quantitative assessment of flash drought. So today I went through and talked about what's unique about flash droughts in the Southeast, the timing, and our hydrologic characteristics. So we're going to take this information and provide a quantitative assessment of drought in the Southeast, specifically focused on flash droughts, and provide some more information on soil moisture-based metrics and monitoring gaps. So with that, I think I'll close here, and we can maybe have some time for questions. In general, flash droughts are particularly acute in the Southeast, defined by their impacts in our hydrologic cycle. Depending on the definition, flash droughts will occur somewhere in the Southeast most years. And the onset of flash droughts in the Southeast can be less than 1 month, yet still have major impacts. And when it comes to predicting flash droughts, I'll just say, flash droughts will happen. And in fact, they may be common in this region. So the best case scenario is to be climate resilient. If you're irrigating, if you're providing conservation practices, and you're providing, you're researching and implementing climate resilient practices, that's the best case scenario. And with that, just another shout out to NIDIS drought.gov on, here's a bunch of great information on what flash droughts are, literature reviews, research priorities, a bunch of really good information. So I think I'll stop there and pass it back over to the moderators.
That's great. Thank you so much, Lee. That was a fantastic overview of rapid onset flash drought in the Southeast. My name is Meredith Muth. I am from NIDIS, the National Integrated Drought Information System at NOAA. And this series is co-organized with the Southeast Regional Climate Center, as well as the National Weather Service. And so right now, I just want to remind you, we have a few minutes for questions. Please go ahead and answer any questions or comments you have for our presenters. A reminder that we will be sending out a recap summary of the webinar, as well as a recording. You can also find these posted on drought.gov. Our next webinar will be August 22nd, and we will be looking at future water availability and stream flow characteristics in the Southeast with a presentation from the USGS Climate Adaptation Science Center, so don't miss that. Right now, we're going to go ahead and jump into a couple of questions that we have. Lee, this first one I'm going to direct to you, and this is looking at the future of flash drought in the Southeast. So as climate change intensifies in the coming decades, what impacts do you anticipate on the frequency and intensity of flash droughts? Is there already historical evidence of more frequent flash droughts?
That's a great question, and in a lot of cases, you know, the most recent projections for the Southeast are essentially not much change in precipitation, but change in its variability. And so you might have higher precipitation amounts, you know, and more infrequent, essentially more variable precipitation. And I'll just say, like, you know, without understanding the confidence of some of the models and the projections, a variable precipitation in the Southeast in the summertime is already an issue, as we just showed here. And so if that variability increases, it does show that there could be, you know, more, we might have more cases of flash droughts like this going forward. But again, you know, I think it's important to note that you know, these could be common, and so they could be already common. The past shows that we have a lot of flash droughts in this region, and this is something that plagues agriculture. And so it's important to be climate resilient, no matter what, going forward. And so, great question. And there are some studies out there that's showing increased susceptibility of flash drought. But I think overall, if the precipitation is going to be more variable, that does tend to implement, you know, more flash drought type conditions.
Great, thank you, Lee. The next question I'm also going to direct to you, Lee. And in addition to agriculture as an impact, there's also, of course, other areas that can be impacted, in this case, wildfire. So the question is, are you aware of any studies or efforts to link flash drought onset to predict increased wildfire activity in the Southeast?
That's another really great question. And I'm not aware of specific research on that, published research on that. However, I will say that is something that I'm personally very interested in, and we have a couple projects understanding the relationship of soil moisture in southeastern canopies, and the live field moisture and the relationship between soil moisture and live field moisture, which is a huge predictor in wildfires in the Southeast. Obviously, there's the big elephant in the room is the 2016 flash drought, where that intensification in the fall led to the major wildfires up in the Smokies. So I think that's a really important topic to be looking forward to and researching. So I'm not aware of specifics on linking flash drought indicators to forest fire in the Southeast. I know there's been some work out west, but that's something I'm interested in, and happy to reach out if you want to talk further about that. Something I'm definitely interested in, especially from the aspect of soil moisture.
Great. We have time for one more question, also for you, Lee. And this is a relationship between flash drought and ENSO. Do you find that flash drought corresponds to La Niña conditions in the Southeast?
I think this is a bit beyond my expertise, understanding the nuances and the cycles of the ENSO. I think typically, La Niña does, on average, would create drier conditions. However, like the major flash drought that happened, in 2016 was in an ENSO cycle, or is in the La Niña cycle. El Nino cycle. So I think there's overall signals, but sometimes it just depends from year to year. But again, it's a little bit beyond my expertise on teasing those out.
That's great. If there are other additional questions, feel free to submit them to myself, and we'll make sure it gets to the presenter. I want to thank everybody for hanging in with us for the full hour. A survey will pop up when you leave. If you haven't taken it before, even if you have, please go ahead and fill it out, especially if there's certain topics that you would like to hear about in the future. And so with that, I'd like to again thank you, our presenters, and wish everybody a wonderful day. Thanks for joining us. Goodbye.